energy, carbohydrate, coal, petrol, natural gas. Today we're going to talking about the topic of energy as for fuel. Now let's start. Now let's talking about crude oil and natural gas. What's crude oil, natural gas come from? They come from the marine organism. The marine organism that is usually they are accumulate as an organic sediment in the ocean. So you can see 300 to 400 million years ago, those small marine organisms that die. And then 50 to 100 million years ago, this in the porous sediment rock that is sipping here. And until today, it be trapped as an oil and a natural gas. Student, when you see I talk oil, I talk crude oil, or commonly we refer to petrol. So here, the crude oil and natural gas will trapping in between here. So the rule will be just like the old rule we talk. Long time, over 1 million years, under the anaerobic bacteria, under subject to heat, pressure at great depth, which reduce all the organic material into hydrocarbon. And this hydrocarbon will trap into the layer of this porous sedimentary rock. So that's what the crude oil and natural gas come from. And now for the following session, I'm going to go detail about crude oil and natural gas. Let's continue. If you study detail about crude oil, natural gas, on these two pictures, can you tell any similar or any different? First, they both are hydrocarbon. And then what's the difference? The difference is crude oil usually are the long chain. And natural gas are the short little chain, small in size. And that is the only difference from crude oil and natural gas. Crude oil consists of a mixture of hydrocarbon. They could be from 1C to 40C. And you have three major types: aliphatic, alicyclic, and aromatic. What's meant by aliphatic? Means they are a straight chain or a bond chain. So they are linear. And then what is meant by alicyclic, aromatic, means they are a ring. They forming into a ring shape. And here you can see some on the picture. And besides, they will have some alkane, alkene, and alkyne. I hope students still remember what's meant by alkene, double bond. What's meant by alkyne, triple bond. And you also have some other tiny bit of other content, like tiny bit of oxygen, nitrogen, or some sulfur as well. And now let's look on to the natural gas. What natural gas will contain? Remember, They are the same thing but of a shorter chain. They made of methane, ethane, propane, butane. What's all this for? Methane, shortest chain, only 1C. 1C. They use for your home cooking. Ethane, 2C. Propane, 3C. Butane, 4C. So that's all the difference. Natural gas are the short hydrocarbon chain. Crude oil are the long hydrocarbon chain. Now let's look on to the physical property of this hydrocarbon. Now let's see. What is this alkane hydrocarbon? They are non-polar molecule. They are non-polar. The electron distribution are even. Electron distribution of hydrocarbon are even. So look at the electronegativities table. I hope students still remember this non-polar covalent. Because these hydrocarbon are very symmetric. They are very symmetric on electron distribution. So they have no charge. They are not a polar molecule. So in that case, what is the attraction force between neighbor molecule? That is a dispersion force exists between hydrocarbon. And so you can see now we on the topic of dispersion force. In our early lesson, we taught water as hydrogen bond, which will be now we on a different focus. And this dispersion force affect a lot of its physical property, like its melting boiling point. The melting boiling point of dispersion force always low. Volatility, they volatile. They easy turn into gas. Solubility, they are soluble in oil. They are not soluble in water. Viscosity, the longer the chain, the thicker they are. Shorter the chain, the more runny they are. So this is their physical property. So student, on this alkane, start to pay attention that they are a non-polar molecule and they form dispersion force between neighbor molecule. Now let's look on to the molecular mass and boiling point. What molecular mass means? The molecule size. As you can see on this, if you look onto this picture on the table, the mass of the molecule, methane 16, ethane 30, the longest 1C 16, ethane 2C 30. The longer the chain, the higher the molecule mass. And now look on to another factor, the boiling point. What did you realize? The boiling points will be the bigger the smaller the molecule, the boiling points is low. Now the bigger the molecule, the boiling points will go higher and higher. So you can see that the disperse force increase in strength with molecular mass. It increases in boiling point with increase in molecular mass. So the small size molecule have low boiling point, and the bigger size molecule have higher boiling point. If you plot this in graph, you can see the 2C have the lowest boiling point, 3C hydrocarbon higher, 4C even higher, up to the 8C. So this is to explain to you they still are under the dispersed force, but because of the size difference, the bigger the size, the higher will be the boiling point. So students, do not confuse that you have high boiling point and what attraction force. Don't say it's because of hydrogen bond. No, they're not hydrogen bond. They still are dispersion force. Then why you have so high? Because you have big in size, not because of hydrogen bond. So students, please learn this concept well. Increase in size, increase in boiling point. Now, of this mixture of crude oil, and on this mixture, you can see on the picture I show, this mixture of crude oil, and you have all sorts. And now this crude oil, how am I going to divide it up into different sides and separately? And I can base on the boiling point different. As the fractional distillation is to separate crude oil or into fraction of hydrocarbon of different molecular size. Repeat, fractional distillation is to separate this mixture crude oil in fraction of hydrocarbon of different molecular size. And it's all based on boiling point difference. Let's see. Look onto the picture on the right. Now, in case if I at a very low temperature, what happened to this mixture? Let's see. You will see at this low temperature, this small short chain hydrocarbon will evaporate and be separated out. And now I'm going to have temperature raise a little bit. And what will happen? And watch. Now, the higher chain, longer chain hydrocarbon will evaporate out by raising slightly higher temperature. And what happens if I raise temperature slightly higher? So, the longer chain will also be separated out. So we base on this difference in boiling point of different size hydrocarbon, and now we can separate it out. And now based on the boiling point, you can see on this the light hydrocarbon, they always will evaporate up onto the top because they are lower boiling point. And those heavy hydrocarbon, they will be at the bottom because they will require higher boiling point. So on this container, I can separate by different temperature in different segments. Now, this mixture of crude oil can be separated out. And now fractional distillation. After I separate them out, is there any use? Yes, very much. Each part are very useful. Let's start. Those 1C to 4C hydrocarbon, we can use it for cooking gas, the home cooking gas. And that's what we use it for, the cooking. 5C to 12C, this is the one that we use the most. This is for our car fuel. That's what our car use. 11 to 15C, aviation fuel. Aviation. 15 to 18C, that is for the truck, the diesel fuel. And diesel fuel. Basically, there is a rule you can see. The longer the fuel, the more powerful is that it can give. And now when you go further, we don't use it to burn anymore. And this is, we use it for lubrication. Lubrication, like your door have a squeaking noise, you're using the lubrication oil. And longer, they're not even a liquid now. They become solid, wax, candle. This is 20 to 40C. They are solid now. And 40C and above, that is where the leftover from this crude oil barrel. And what do they use? They mix it up with the sand, heat it up, and roll it onto the road. That is the road bitumen. And that is what our road made of, the road bitumen. So you can see in this fractional distillation, once they divide up the crude oil into different segments based on the size, and each one serve great use.